Hi, this is podcast 1-1, which means the first podcast of the first class session of OChem Prep. So we will be covering Lewis structures and line structures in constitutional isomers. Okay, so to draw Lewis structures, we have to remember the way we drew them when you were in introductory chem or gen chem. If you had nitrate, NO3 minus, what you do is add up the valence electrons. So nitrogen has 5, oxygen has 6, so you have 3 times 6. And you have plus 1 for the minus charge, and you get a total of 24 electrons. You'd put nitrogen in the middle, because you always put the least electronegative element in the middle. Put the oxygens all around it, and each bond is worth 2 electrons. And then you try to fill up the octets, which I don't really like the term, but we're going to use it anyway. Put 2 bonds here, dot, 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 and then put dots around everything. And if you add it all up, we should be at 24. And all of the atoms have 8 electrons around them. Now, if you look through, nitrogen came in with 5 and now has 1, 2, 3, 4, has a plus charge on it. And these 2 oxygens have minus charges. That is nitrate. Well, nitrate is an inorganic compound or an inorganic ion. We're going to be drawing structures that are organic. And they're the same thing, only we sort of look at them a little differently. So I'm going to erase this pretty quickly. Get rid of that. And then we're going to go into some organic compounds. Let's go back here, get rid of that. Okay, so what we're going to do is we're going to come up with rules. Now these rules, of course, can be broken, just like any rules. We'll start with methane, which is CH4. CH4, again, 4 for carbon, plus 4 times 1 for hydrogen, so we have 8. And this is not hard. We'll put carbon in the middle, put the H's all around, and you get 8 electrons, 8 around carbon and 2 around hydrogen. And we have 2 rules. Carbon takes 4 bonds, and hydrogen has 1 bond, which means hydrogen never can be between, but there are some cases in which hydrogen can be between. Well, we're going to just march ourselves across the periodic table. So it goes from carbon to nitrogen, so we'll do nitrogen combining with hydrogen. And again, we have 5 plus 3 is 8. So again, we put nitrogen in the middle, put hydrogen around it. Now if you look, 2, 4, 6, we need 2 more. We're going to put 2 dots on nitrogen, so we have a lone pair. Pretty soon we sort of lose lone pairs, but now we have another set of rules. Nitrogen takes 3 bonds and has 1 lone pair. Okay, marching across the periodic table, we go to water, and water will be, again, 8 electrons. 2 plus 6 is 8. Put an O in the middle, put H's on either side, and we need 2 lone pairs. So oxygen's rules are 2 bonds plus 2 lone pairs. And that's true whether it is a double bond to oxygen or a single bond to oxygen. And the last one we're going to look at is, well, HF. Even though it's not organic, but we'll do HF, and that's the structure of HF. Fluorine, chlorine, bromine, and iodine. These are the 3 we use in this class. We don't use fluorine very much just because this bond is very strong. And we don't use iodine very much, believe it or not, because it's expensive. So we tend to use chlorine and bromine in this class, even though we're not actually using them. But most of the time we talk about compounds of chlorine and bromine. And so they're like hydrogen in that they form only 1 bond and are not between. So chlorine, bromine, and iodine are 1 bond with 3 lone pairs. Well, now we have enough rules that we can draw lots of different structures. Okay, so we're going to start with a series of hydrocarbons or carbon-hydrogen compounds. So we had, I have to get my pen ready. We had CH4, that's methane. The next one is C2H6, that's ethane. And we're going to learn nomenclature in the next podcast. C3H8, you can see the pattern forming, C4H10, C5H12. So the rule is, if you have Cn, you have H2n plus 2 is the number of hydrogens. And if that's true, you have no double bonds or triple bonds or rings in your structure. It's called an alkane, the simplest kind of hydrocarbon. Now, if we were going to draw these, I would put C's in the middle and put H's all around. And then it follows the rules. And if you counted up the electrons, if you follow the rules, you don't need to worry about all the electrons. But if you counted it up, it would be 8 plus 6 is equal to 14. 2, 4, 6, 8, 10, 12, 14. It works. Now, if you look, here's C3H8. Now, I'm already getting tired of drawing all those H's. So I can put those dashes for hydrogens, or I can just put hydrogens on them. But pretty soon, it just gets awkward to draw all these H's. And so we're going to find a way to get rid of all those H's. Now, if I drew propane, C3H like that, or drew it like this, even though it's bent, I'm just going to put the dashes here, it's still the same thing. Because if you look, this CH3, this C is attached to 3 H's, so is this one. This C is attached to 2 H's, so is this one. And this C is attached to 3 H's, and so is this one. So even though they don't look alike, they are exactly the same thing. And I had one student say, you draw a pencil through there, and if you can touch all the carbons in the same way in both structures, then you know that they're the same thing. Well, now let's go to C4H10, which is a little more interesting. So I'm going to put 4 in a row. And then I'm going to put in the H's as dashes. So here they go. That's one way of drawing 4 in the row, but there's another way. Looks like this. Now, I have one extra carbon. If I put it on either end, it's the same as the one I drew here. But if I put it in the middle, it is a different compound. So if you look, I'll add the H's. These two things are what we call isomers. Isomers have the same formula, but they have different molecular structures. Now, there's going to be all sorts of different kinds of isomers. These kinds of isomers are called constitutional isomers. They are different compounds. They have different boiling points, melting points, different properties. Now, as I said, it's sort of tedious drawing all those H's. So what we're going to do is we're going to draw it like this. This compound right here is the same as this structure here. Each end and each vertex is a carbon with the right number of H's attached. So if you look, an end has 1, 2, 3. A middle has 2. A middle has 2. And an end have 3. This one, to draw the structure, you go like that. And I'm going to put it up. It doesn't matter, up or down. It's the same structure. Here is the carbon. It has 1 hydrogen in here. So if we count it up, sometimes I count hydrogens like this. Remember, these aren't lone pairs. These are hydrogens. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1. So if you look, both of these are C4H10. They are isomers of each other. So if we go to C5H12, I'm going to draw an arrow down here. Here is the way to draw C5H12. 1, 2, 3, 4, 5. That's C5H12. There's only one way to put 5 in the row. So if we want to go to 4 in a row, we're going to go 1, 2, 3, 4, just like we had up here. But now we have one more carbon to put on it. If we put it at either end, it becomes a 5 in the row. So you can put it here. Now, if you put it at this carbon, it would be the same as if we put it at the other one. So if I draw this, these two are not isomers. They're the same thing. So part of learning how to see is making sure you know which is an isomer and which is not. So these two, if you look, are put together the same way. This CH3 is the same as this CH3, as is this one and this one. These two are the same, these two are the same, and this is the same. So those are isomers. Now there's one other isomer of C5H12. Put 3 carbons in a row. Now, if you have 2 more carbons to put on there, you can put them both in the middle. Now, we have 3 different isomers. All of them look different. Now, somebody would say, why don't you do this? Put those 2 carbons like that. Well, if you look, this structure, I'm going to label it 1, 2, 3. This structure is the same as number 2. Try to convince yourself we have 2 1-carbon units attached to a carbon with 2 H's, attached to a carbon with 3 H's. So there are 3 isomers of C5H12. So in the next podcast, we'll learn how to draw structures that have double bonds, triple bonds, or rings, or are attached to chlorines, bromines, or iodines, or nitrogens, or oxygens.